Good to see you all.
You too. Have you submitted your talk to GraphQL Conf yet? That goes for all of you.
So yes, so I've submitted the panel.
Excellent.
And I added it to our agenda for today to touch on that. But yeah, so we're submitted. So now hopefully the TSC will like it.
Are you hosting this meeting, Stephen? Oh,
The
isn't it?
Well, sorry, what was that?
Who is it? Alex that normally hosts this one?
This meeting right now.
Yeah.
Steven, if you want to do it, you can go for it. I got some stuff I gotta take care of over here.
Okay. All right. So let's see here. Do we have quorum? We had 7. Yep, let's start. So we'll go down. Let's start by introducing everyone in the order that we are on the attendees list, starting with Benji.
Hi everyone. There's 2 of me today, but this is the one to pay attention to. I'm Benji.
I think Alex is. Oh.
Yep. Hey, I'm Alex. I'm here as an independent.
Hi, I'm Jeanette. I'm from Meta.
Hey, I'm Calvin from Apollo.
I'm Jordan, also from Meta, and I work on Relay.
And I work at Coinbase.
I'm Steven. I work at Netflix. All right. Thanks you all for joining. And now, anyone be willing to take notes for us today?
I've volunteered my computer to be a camera, so I'm unable to.
Let's see, 5 minutes. One. I see Benji's typing in there.
Yeah, I suspect I'm going to be talking quite a bit, so probably best I don't take the notes.
All right. Anyone else able to take some notes? I'll help out as well.
I can
All
certainly
right.
try to hop in. And do we? Where are we doing the notes at? Are they?
So we have a live notes doc that is attached.
I put a link to it in the chat.
There we go.
Cool,
Thank you.
thanks.
It's like we
Yeah.
have Tom here as well. We should give him a chance to intro himself.
Oh yes, I didn't see that.
Sorry, I
Tom.
don't great. Hi, I'm Tom from M&S. I'm going to keep the camera off because I'm eating. Sorry.
Awesome, great to have you. And if you get a chance, you can add a PR with your name and the attendees for posterity.
I tried that. It doesn't seem to like me very much, but I'll give it another whirl.
Okay.
If you need help figuring that out, drop me a message on Discord or something like that, and I'll help you get it sorted.
Thank you very much.
Or on GitHub, that's fine too.
All right, so our agenda today, we have previous action items, and then take a look at proposal, and also briefly talk about conference panel. So let's start with previous meetings action items. And let's see, do we have anything ready for review? Nothing there. Any open action items? I have an old item here, update README with links to other discussions and RFCs. Is that still needed, relevant? Let's see. Share my screen here. So we're all on the same page.
As a question for Alex, I guess.
Yes, this was under assigned to Alex.
I believe that's been done.
Okay,
We can close that one.
cool. All right. And now let's see. I think I'll skip the queue here and go with the short agenda item first. And so we have officially submitted a panel discussion for nullability. And so the next steps there are we'll go through the official process to so it's not yet guaranteed that it'll fit into the conference schedule, but hopefully it will, because I think this is an important topic. And then we'll finalize the the panelists and make sure we have group that is all able and willing and available come September. And then we'll narrow down our discussion topics and how we want to use this time on stage to communicate with the GraphQL world about what's happening here. So just want to put that out there. But any thoughts, questions on that for today?
Yeah, I just want to say I'm submitting a talk sort of more broadly about the semantic nullability idea and try to capture what our current thinking is, what it will be at that time, obviously. And then also Itamar is submitting a talk specifically about the catch directive and its role, specifically about its value, but then also I think he'll touch a bit on how it ladders up to some of this work or helps enable it.
It's exciting. So we'll have some good content about nullability. And then if there's nothing else, then we can go ahead and move on to our big topic for today. And I'll pass it to Benji.
Hello again, folks. I'm going to attempt to share my screen now, which is always a fun exercise. And guess the entire desktop, just for rare. All right. How do I get rid of these faces? There we go.
I think we're still seeing someone else's screen.
Do I need to unshare?
I'm sharing maybe the wrong.
I think. Okay.
Yeah, Stephen, I think you need to stop sharing your screen, maybe.
Trying to figure out how to do that.
That always happens to me with our internal one. Where like you're like, oh, I don't want to see this thing while I'm sharing my screen, and then the button goes away. Stop this.
Yeah, there should be a like a zoom bar at the top or bottom of your screen that you can click on.
Yeah.
And then there's
Let's see.
Admin, can anyone?
Stop video. Pause share.
I'm admin, but
Did that do it?
no. You could leave the call and come back. That'll do it.
I pause share, stop share. There we go.
There we go.
Yay.
All right.
Most relatable experience ever.
All right, that's looking better. Okay, cool. Welcome everyone to this short talk on semantic nullability schema. True nullability indication. I should warn you, I'm going to read these slides. These slides I basically wrote on the train on the way here. So this is unrehearsed. It's not really a talk so much as me just trying to introduce you to things. True nullability indication for the simplest and most advanced GraphQL clients. Now it all comes down to error handling. Imagine that you've got a type like this in your schema, and you know there's a rule in your schema that every user belongs to an organization. So we want organization to be non-nullable. But what happens if the service that serves us the organizations has an issue? That's going to blow that up. And that then means that our entire user object in this case is going to blow up, and potentially further objects, because the null may bubble further. So we mark that field as nullable. GraphQL is nullable by default, so they can handle these errors. But now it's a little bit confusing, because it looks now like a user doesn't have to belong to an organization. They do. It will only be null if an error happens. So the combination of error boundaries with nullability is not always desirable, as we all know. So really, it comes down to two types of client. Traditional clients look at the query that they've written and the types in the schema and how to define the type of the data that they're going to receive from this. And the types say, because they know that organization is nullable, because it can handle errors, that they have to now handle this null, even though they don't want to. They know that this shouldn't normally happen, but we're going to make them handle it anyway. Error handling clients want to look at the response holistically, factoring in the errors that are returned and their paths into their interpretation. So they want to know that user will have an organization unless an error happens. In this case, they don't want the maybe, but they do kind of want an or error. And really, in GraphQL, the or error applies to every single field. Every single field can throw an error. Error handling clients don't want nulls to bubble, and they want to know the true nullability in the schema. They want that little exclamation mark there so that they don't have to have maybes in their client code. So it all comes down to two modes. Let's call the current way that GraphQL works traditional mode. And let's rename the non-nullable that we have in the current GraphQL spec to strictly non-nullable, since there will never be a null in a strictly non-nullable position. The nulls will bubble and they'll blow up the next layer or the layer after that or the layer after that. So strictly non-nullable, never, ever, ever will there be a null there. Let's call types that are null only when a matching error can be found in errors semantically non-nullable. They will never be null unless an error happens. Now let's introduce a new mode in which we disable null bubbling. Let's call this mode no null bubbling mode. There's a little bike shed alert there because I'm sure we'll come up with a better name. Whenever an error or a null occurs in a non-nullable position, the position will become null and will not affect parent selection sets. It won't blow things up anymore. So with no null bubbling, all strictly non-nullable positions in the schema become semantically non-nullable. Every single position that was previously said to never be null now can be a null so long as there's an error there, which is the same as semantically non-null. So clients in this mode are only dealing with one type of nullability, which is semantic non-nullability. The strict non-nullability effectively goes away. So there is only semantic non-nullability. There is no observable difference between the two types. Both of them may produce an error, and if they do, the result will be null, and neither of them will produce a null without there being an error. So what's the challenge? Well, it all comes down to syntax. GraphQL SDL is used both when writing schemas and to represent the schema when developing client applications. For example, the input to lint tools or type generation, that kind of thing. We need a way of representing these two different types of non-nullability in the SDL. But there is a vast number of GraphQL documents that already exist out there. GraphQL has been open source now for about 9 years, and it is used very widely. There is a lot of GraphQL documents out there. There are also schemas that are composed from multiple SDL files, and some of those SDL files may be files that the schema authors don't actually control themselves. Maybe they're controlled by another team. Maybe they're external entirely. There are clients that might mix in their own client schema extensions. There's SDL used by tooling for type generation. There's all the documentation that we've ever written about GraphQL and that's ever been written about GraphQL has all these old documents in. So we can't just change the meaning of the existing syntax. Everything would break, right? Everything would break. Well, can we? Maybe if we do it locally within each document, we could do this. We could change the syntax. And if you think about it from a schema point of view, all that really matters is the actual types that exist in memory and the introspection results that will be returned to clients. The SDL isn't really a concern for a running server. It's more of a build artifact. So it all comes down to documents. I'd like to introduce you my idea of pragmas. Pragmas would be little instructions that go at the very top of a GraphQL document and can change the way in which that document is interpreted. And our first one could be semantic nullability. Again, bike shedding, we could change the name. By adding a pragma at the top of the GraphQL document, we can change the meaning of the syntax in that document, and that document only. It won't affect the rest of the schema. It will only affect how that one document is interpreted. So with pragma's semantic nullability, we can make it so that semantic non-nullable types are represented with a bang, and strictly non-nullable types, those traditional ones that we have today, would be represented with a double bang, for example. And that might look something like this, where the ID is never ever expected to be null, and the organization is null only on error. Now, migration to this would be really easy because we can handle it on a document by document basis. All we need to do is add pragma semantic nullability at the top of the document, and then we do a find and replace of bang for bang bang everywhere throughout the entire document. And because I'm a Vim user, I have to appease the Vim gods by telling you all what the Vim command for that would be. Now, when a client in traditional mode introspects the schema, we would make it so that it would only see the strict non-nullability. It wouldn't see the semantic one. And that way, it would only be able, it would represent things exactly as it does currently. Nothing would change. They would still use bang to represent strictly non-nullable, and there would be no bang bang. When a client in no null bubbling mode introspects the schema, as we saw earlier, there is no difference between strict and semantic non-nullability. So it could also represent its semantic non-nullability with a bang as well. So it would also only see the bang character, never the bang bang, but it would have that pragma at the top to say that the bang means something slightly different. Now, whichever mode you're in, if you want to, when you do the introspection, you can also just say, tell me the true nullability of these types, in which case you could then represent it with the full SDL, which would have the pragma at the top, and it could also use the double bang character to represent where there are strict non-null types. And that would be useful if you have both types of client, like in, for example, a big monorepo, but it also would be useful for things like Relay, where Relay might want to run all of its requests in semantic no null bubbling mode, and then emulate the traditional mode from then onwards. So, bit of bike shedding. Symbols. We could choose the syntax here, right? We've added a pragma, which means we can choose whatever syntax we want. So option 1, which is the one I've proposed, is adding a bang bang for strictly non-nullable. Option 2 would be going with the previous proposal of having a question mark for nullable, the unadorned type for semantically non-nullable, and the bang for strictly non-nullable. So I want to tell you why I've chosen option 1. There's a few reasons. One is it's familiar syntax in both of those client modes. You just have the unadorned type is nullable and the bang type is non-nullable. Whether it's strictly or semantically non-nullable depends on your mode, but it's just the two standard representations, syntaxes that we've been working with throughout. It still holds nullable by default. That unadorned type still means nullable. So you have to add something to it to change it from the nullable state. And it also shows a clear progression of non-breaking changes. You start unadorned, then you can add an exclamation mark, and that is non-breaking for output types. And then you can add another exclamation mark, and that is also non-breaking for output types. In the other way, it's not quite as clear, I would argue. And also, it keeps the syntax available if we wanted something like a question mark to represent optionality of something, for example, for input types. It's always good to preserve our options. That said, option 2 is still perfectly valid, and I'm not ruling it out in this proposal. I'm just telling you which one I prefer. So it all comes down to error handling, 2 types of client, 2 modes, per document syntax, and representation in introspection. So this very much builds on everything that everyone here has contributed to the Nullability working group. It is very much just a taking apart and putting back together again of all the different ideas we've discussed over the last, what is it, 4 years now, going back as far as client-controlled nullability. I do also have a document, which I believe is linked in the agenda, that has a more complete form of the proposal, so you can read more details about it there. But that is essentially what I propose currently. There are still holes to be smoothed over, but any thoughts?
Did Lee already look at this?
I sent it to Lee about a month ago, but I haven't received any acknowledgement from him. I don't think he's had time to look at it yet.
Got it.
I guess I'll say my gut feeling is that this solves many of the problems that the previous sort of ideas had, which felt very hard to overcome. And this feels much more palatable to me, in terms of setting us up for, the code that you would actually write day to day is sensible, and we can get there without, throwing away everything that already exists, or just, being a really bad breaking change for the language. And I think the insight that how tightly it is coupled with null bubbling took me a while. You helped me see the light. But yeah, I think overall I'm favoring this over anything that we've seen before.
Yeah, and I'll say, Benji, first, thank you for like presenting it and the way you did. I mean, that, that's like a conference quality presentation right there, just for the working group here, and it's really helpful. I've had this memo staring at me, and then but then that just kind of distilled it down, and I think this does seem like it's distilled. This proposal is distilled what we've been bouncing around and pulling in these concerns, like how do we address schemas that are already out there and everything, and yeah, I do think this is the best form so far of new nullability handling, whatever we can call this more generally. And yeah, probably the potential challenges for getting this through. I'm thinking introducing the idea of a pragma is that's a pretty pretty big thing. But I like how it is like not limited necessarily to semantic nullability. It's a kind of a general way that we could potentially use in the future for GraphQL, and it seems like a really kind of a simple standard way that we can then move forward with the SDL and stuff. So I like that approach. And probably my only bike shed would be on the syntax. Because I think I am liking option 2, and mainly just because of, I think, the second bullet point of like preserving nullability, nullability as default, and with a move to semantic nullability, I'm wondering if actually the opposite default makes sense.
It's an interesting point, and if you're running it in no null bubbling mode, then you would again still only be dealing with those 2 things. So you'd be dealing with int ? Or int, and you would never see the exclamation mark. there is interesting things that haven't been fully figured out yet. For example, what do we use for input types? Do we see them? Do we represent them as semantically non-nullable so that we don't see another character? Are they where the bangs would appear in option 2? Like you would only see a bang when it's an input type. So there's definitely questions still to be figured out around that. But yeah, that's a problem for either syntax. I think also seeing question marks there would make it a lot clearer that you're dealing with a different beast. But I would argue that having the unadorned type mean very different things in the 2 different modes is quite, I see that as quite a barrier personally. But I know that others don't see it as such a barrier.
Tom?
Yeah, so like really great proposal. I really like the idea. I'm still really wrapping my head around it. So correct me if this question doesn't make sense or you think it's answered in it. Have we given it a thought in the federated world? So what if one of my subgraphs wants to be use the pragma? Does that make the whole supergraph pragma? Or how are we handling just that one subgraph doing that? Do we ignore it? Do we control that at a supergraph level and say, dictate to the subgraphs that you are this? Does that mean what people's thoughts on that?
So essentially, I have thought about this a little. The issue is that your supergraph, sorry, can't express that it supports no null bubbling mode if its subgraphs do not. It kind of can, but it's still going to suffer the blowing up of the selection sets. And then that would mean that the error paths wouldn't be correct for what someone would expect with no null bubbling. So you'd have to do transform of those errors, and you'd have to also pretend that the error came from somewhere where it didn't, which is not really true.
Correct.
It's not semantically correct. And it then means that clients like Relay would make bad assumptions. So essentially, a supergraph could absolutely send a no null bubbling mode request to all of its subgraphs, but it can only send no null bubbling responses to its client if every single subgraph involved in that request was also in no null bubbling mode. I didn't present it in this presentation, but in the document, I also talk about like the network format of what this might be. And essentially, when you send your GraphQL request, normally you would send it with like operation name, query, variables, that kind of stuff. You would also get an extra key, which would be something like, nullability semantic or no null bubbling true or whatever, bike shed. We'd have a thing like that we would send. And if the server supported that mode, it would include something similar in the response. So when you get a response back from a server, if it doesn't have that key, it doesn't support this new mode, and you just have to interpret it in the old mode instead.
Yeah, okay. So it would have to be sort of the whole ecosystem would have to decide. Like the supergraph, say gateway team would have to dictate their subgraphs, and then their subgraphs would have to. Okay, yeah, that makes sense.
It's that, or they have to never have non-nullables, or they have to never throw an error in a non-nullable position.
But it's worth noting that as a server, I can support no null bubbling without also supporting these 2 types of nullability, right? You can just say, well, I only have true nullable, true non-null fields. That's what my schema says, but I can just not perform any null bubbling.
Yeah,
for those.
it would mean anyone who did a traditional request against you would just see everything as nullable. If you only had semantic. Is that what you're saying?
No, if you only have true non-null.
Strict or semantic?
Strict.
Oh, okay.
Right, because that's
The bubble.
the world that exists for everyone today.
Right.
Right. And if I'm a server and I don't know anything about semantic non-nullability, I can still support a no null bubbling mode.
By just not bubbling.
By just not bubbling, which is a relatively trivial update for any server.
Yeah.
Because it's just doing less work
Yes.
than is already being done. So I would imagine it would be easier for the ecosystem of all those executors in the subgraph to be able to support that, even if they don't have all this additional information about the subtleties of its types.
Yes, that is absolutely correct.
But I think that is a good segue into another thing that I appreciate about this is the observation that even for existing clients who predate any of this discussion, you can synthesize a schema for them, which represents the state of the world that they will observe, which I think is actually really powerful in terms of bringing the ecosystem along. That you can sort of, as an outside controller or user of a client, even if it doesn't have any special knowledge of it, if I know I'm going to throw away all responses with errors in it, I can just say, okay, I'm going to transform the schema before I hand it to you, and I'm going to set this flag when I make my requests. And that's enough to buy me a bunch of additional value without that client even having to have any code changes.
Yeah.
Benji, your GDoc proposal doesn't yet have option 2 in it, does it? Is that right? Or am I missing it?
No, I didn't put it in there.
Okay.
It was already large enough without the subtleties of bike shedding.
I guess after this proposal is, you know, I don't want to get ahead of myself, but after it's implemented, after it's been released, do you imagine all, or at least most new applications would have Pragma at the top of all their documents?
That's a good question. So Lee and I discussed nullability at length about 6 weeks ago or 5 weeks ago, I'm not sure. And we went through basically everything that this working group has discussed as much as we could. And that's what led to this revelation, which Lee helped very much towards, but hasn't commented on the final proposal. So I've lost myself. What was the question?
Why, or will the end state be that everyone adds this pragma in the new steady state of the future?
So what was really interesting about that was when we realized that the SDL itself was kind of the problem. And also, like, SDL is kind of a secondary thing. Like, really, introspection is the source of truth, and SDL is then a representation of that, but also a way of making a schema that has that introspection. But really, introspection is key. So it really depends on what types of clients you're using. There's a particular type of client, which I would call I don't know what I've called it, but it's a null handling client that handles nulls by just throwing out any request that has, an error handling client that handles errors by just throwing out any request that has any errors. It doesn't care what they are, doesn't care what position they came from, it just throws out the entire request. For them, they would want to use the semantic non-nullability because they know null only on error. Well, I throw out all the errors, so it's never going to be null. So for them, the new schema makes sense. For traditional clients that want to use simple type generation to look at the data, they, I think, would want to use the more traditional mode. And then for the slightly more advanced, or much more advanced clients potentially, like Relay, for example, Relay wants to use the semantic mode, the no null bubbling mode, but it might then want to actually re-implement the other mode for its consumers. So I think I think they're both useful. I don't think that it's necessarily this is like a step and we're moving to GraphQL 2.0. 2.0 is going to have no null bubbling at all. That was a mistake all along. I don't think it was a mistake, and I think it makes sense for some clients. Yeah, maybe that answers your question.
Got it. Yeah. I guess I was wondering if a new service was likely to want every schema document to have a pragma at the top, if it made sense to also have some sort of global option for the service to just be the whole services, or I don't know. sorry, I'm thinking right now, but the if that was the case, then it would become more difficult to read isolated SDL documents, I guess, right?
That was one of the many reasons why I felt that the Pragma approach was the right approach, because it keeps it documented. So rather than having to then go and reference like another file that might define the schema with a given directive or something like that, you just look at the file that you're looking at and you just see if the very first line of it is a Pragma. And part of the proposal for Pragma is that they must be the first things in the document. Pragma must. So if the first thing you read isn't the word Pragma, then it's in traditional mode. Simple as that.
Cool. Yeah, that makes sense.
One thing that you mentioned was this idea of like a very simple error handling client. And it's made me think that, we talked about how a sophisticated client like the one Jeanette works on, like the one I work on, which maintains a normalized store, would really prefer not to have any of this null bubbling happening. But it also occurs to me that for this very simple type of client, which is going to discard any response with any error in it, you're correct that they can observe the semantic nullability of a field, but the error bubbling that they would like is actually just stop executing as soon as you encounter the first error. And it makes me wonder if there's value in having it not be simply binary, but like leaving ourselves at least open to, if not including, that as a separate error or null bubbling or error handling mode.
Yeah.
Which would similarly observe the appropriate types based upon that execution mode.
I think that makes sense. And maybe, for example, that would lead to more the key being like errors, and then the value of it being something like traditional or like bubble, versus semantic versus stop.
Right.
But yeah, I think not choosing a Boolean would be wise, and choosing a string or a number instead would be a better choice. But there are also like other clients, for example, Fetch, right? If you're building an application with Fetch, then most likely you don't want to do all of the complexity of like a normalized store and all that other stuff. So really you want strong types that can apply to that data. And you may or may not want to look at those errors. If you want to support partial failure, which is really one of the major features of GraphQL, then you can still do that in a traditional client, right? We've had that in GraphQL since it was released. So I think for simple clients like Fetch that you're just using without adding another dependency, the traditional mode is what they would choose.
I think there is something there too. So I think one of the parts of that's really elegant about the proposal is that like any one client can just see the sort of simplified version of the schema. But I'm thinking about a fetch client, right? Who's maybe not even having types. Maybe they're just like, oh, I looked at the schema and I decided what feels like a trust based on that. In that world, I think it is interesting that both gradients of non-nullability actually would be helpful to me as a developer, even if I can't say, well, I can prove that this is never null. I say, well, I know that that it probably won't be null. And so like I could assert it away, or I could throw an error if it happens, or something like that. So I think it's interesting to consider that there's, even for the people who are going to encounter null in those places, as just like a pragmatic choice that I'm making as I'm writing this code, being able to see that actually helps me know. And conversely, if I don't see that, I know, oh crap, this really can be null. I've gotten used to a world of GraphQL where everything's null, and I'm just like, screw it, I'll just throw on every null. But in this one, oh, this is actually a serious null.
This is a deliberate null.
Yeah.
A semantic one.
So I guess where that leads to is, I wonder if we want a world where most people do encounter the richer schema, and rather than operating off one that's been translated for the purposes of a given client.
So this is an interesting thing that I deliberately skipped over in the presentation, but one of the things that I raised in the presentation was that in no null bubbling mode, semantic non-nullable and strict non-nullable are indistinguishable from an observational point of view. But that's not true in traditional mode, because in traditional mode, a semantically non-nullable position will never be null unless there's an error, which is different from a nullable field, which can just be null on its own, that's fine, or a strictly non-nullable field, which will never be null ever under any circumstances. So actually traditional mode does have these three things, but the semantically non-null can be treated as if it were nullable. You lose a little bit of the nuance there, but in doing so, you keep this like simplicity of only having nullable or non-nullable, whether that's strict or non-null or a semantic. So I don't think that we should try and too explicitly support that, but if they want to, then absolutely they can look at the full schema and then they can build this intuition for themselves. But I don't think that should be factored into the normal like client representation. Yeah, I petered out a little bit.
So I guess my question is if I have maybe a not a monorepo and my client lives in a different code base than my server, and I want to check in the schema that my server has, would the recommendation be that I check in one that has been fetched via introspection for my client's use case, or one that is rich so that I, as a curious product engineer, can go see the real source of truth?
Yeah, I think that's a team decision. If you also have your server in that repo, then most likely you would keep the full nullability one. If you've got a client like Relay in there that might be using throw and catch directives or whatever, then for them, the likelihood of different things throwing may arguably be different. So they might also want the richer one. But I would say that generally, if you aren't in either of those situations, then probably just the one that is observably what you will receive is sufficient. So I guess it depends on the confidence levels of your team, whether they want to be able to deal with the two levels of nullability or whether they want to keep it simple.
So I'm at actually just happened to be like at a team offsite, and so I did a presentation for my team yesterday, like about this whole thing, partially to like force myself to talk through a bunch of stuff and understand it more deeply, right? And the thing I noticed is that like they all got really stuck on is like the like strict double bang syntax, because I think it wasn't and certainly partially could have been my fault for like not describing it well enough, but I think I kind of was hoping you could describe that a little bit more of like, as a schema author, how do I know what to use? If I'm writing a new type and I'm adding new fields, it's like, how do I know, like, because in our situation, right, it's like we might be experts on the schema, but the people necessarily writing the schema aren't, right? They're just kind of like, oh, I'm exposing some new structure. And like, I think there's confusion of like, what do I use? Like, what do I put here? And how do I decide and make that choice? And I was wondering if you could like talk through that a little bit of like how you would make that decision as a schema author if you're creating some user type like you had in your example there.
Absolutely. So you start with nullable. Everything's nullable by default. That is the right default choice. If you're not sure, you make it nullable. Nullable is the most future compatible type that you can choose. You can always make it semantically or strictly non-nullable later. If you start with nullable, everything's fine. Then you figure out, is this thing guaranteed? Ignoring errors, is this thing guaranteed to never be null? Not just not to be null at the moment, but never in the future of our business, ever going to be null. If that's true, then it's semantically non-null. So, for example, if you say that a user must belong to an organization and that will always be true, then that is semantically non-nullable. If you say a user will always have a username, then that is semantically non-null. You can never conceive of a situation in which you would allow a user to register without a username. Yep. So those kind of things created at. Well, everything needs to be created. That's probably semantically non-null. How can a thing exist that was never created? Getting into philosophy. Then then you go with the things that, is it guaranteed not only to never be null, but to never, ever, ever, under any circumstances, throw an error? And that is what the double bang should be. And that is also what the bang should be in current GraphQL, which I would argue is currently overused to make engineers' lives easier. But that bang is meant to be there to say, you know, this thing's not going to, if this field were to go wrong, it's because the entire object is now meaningless. So like the ID of a user, the user is meaningless if they don't have an ID. How do I like write them to a normalized store? How do I reference them? It doesn't mean anything. So only in those incredibly rare circumstances would that ever be a double bang. Now, you might want to use that as well for things like username, which you know will always be present. If you've managed to load the user object, then you will have managed to load their username, presumably. That's not strictly true. If you later make it so that you use, for example, a federation-based architecture, and you've got user objects that are defined over here and user objects with the username defined over here, it might be that you can't actually request this. So there are situations where it is only semantically non-nullable, but you might say that situation is so unlikely that we are okay with putting a double bang. But the double bang syntax is awkward deliberately because you should only use it where you're really sure that that's the thing you want. It's the most scary of the combinations, and for good reason.
In the meta schema building tool, the way you describe a field that has this property, which is the current strict non-nullability, is it has nothing to do with nullability. You have to label it kills parent on exception. And I think that like really is the right mental model for like, oh, this is not about nullability. This is about whether I should murder my parents.
More philosophical discussions, yeah. So like to dig in a little bit further, like, because you know that behavior doesn't actually happen when you in semantic nullability mode, though, right? Because like there is no non-bubbling, and so I think that's what's kind of like tricky, is that like the client, like you're annotating the schema saying this will never have an error, but as far as the client's concerned, it still thinks that field could have an error.
Right, which is why I would argue that by default, if you are using a no null bubbling client, you should see the schema that only has semantic nullability and then never contains the double bang.
Yeah.
And that's why I said before, you would only opt into the full schema if your engineers are sufficiently confident in the system and understand it enough that actually this extra nuance isn't going to confuse them. I think the best thing for most people is to have unadorned means nullable and a bang means non-nullable. And then what mode you're in says whether that is a strictly non-nullable or a semantic non-nullable. And you don't worry about the double bang. The double bang is almost exclusively reserved for actually the people who are defining the schema and people who are writing advanced GraphQL clients that want to be able to add emulation of old mode on top of new mode.
So, but if we take that, like, let's take created at, right? Where like, we're going to say created at will never have an error, and it should always exist. And like, so we're going to double bang that, right? I guess I'm still kind of struggling to understand, like, I guess maybe take your position here with Relay, Jordan, like as a concrete example. Like, will Relay treat that field differently if it has a double bang than if it has a bang? Like if that field comes back and like actually does error,
no,
does it treat it the same?
Who care about that distinction are the people who sit at the intersection of want to deal with partial responses, but aren't sophisticated enough to handle errors client side. So there's like the people at the people who just throw away any response with any errors on one end of the spectrum. There's people who are clients, right, that are handling errors at a more sophisticated way at the other end of the spectrum. And then there's this narrow slice who I don't know if we have a good sense of how thick of a slice it is, of clients that are like, well, I can't handle errors for you. you want to be able to render from partial response, and we have type system built in somehow. And like those are the only clients for whom there would be a difference between those two things. And for me, it feels mostly like a bridge, right? It's to take what we have today and give it a place to live more than it is like we really, if we were starting from scratch, we really want to make sure we can express all of the different nuances of nullability. So I think
it's the intersection of those that want to deal with errors, and you're saying it's what is it? The
that want to render even in the face of errors, and have some kind of type generation, but don't have any kind of more sophisticated error handling.
Yeah,
which, to be honest, is all clients today. So like we should not just say like that is a solved problem.
It is the vast majority of clients. Only the ones that throw out errors, are different today because we've given them no option. But I think it will still be a major portion of GraphQL clients. Anyone who's using fetch but is generating types from their queries, they will be in that boat where they want to know the traditional nullability.
Yeah, and I think it's also worth noting, I was just talking with Patrick from the Strawberry GraphQL server earlier today, and was reminded that like they don't do nullable by default. Like they just follow the type. So there's any schema you have that you build to Strawberry is going to have bangs all over the place today. And so I think like I've been thinking about it so much coming from like, oh, we start with a world of null everywhere. How do we solve that problem? But there's also this world where like, no, you have bangs everywhere, and you can, and like, how do you get from there?
And arguably, option 3 of the syntax is that we don't allow the double bang in like array positions inside of arrays. We only allow it field level. And instead of having it, we add a kills parent on exception directive. So it could be we just stick with the 2 current stuff and a kills parent on exception. But the main thing, and I'm not certain whether this was clear, so I'm going to repeat it, but I am repeating myself, is when a client like that, when a client in no null bubbling mode performs introspection, it will never see strict non-nullability. So if it were to generate an SDL from that SDL would never have a double bang in it. So there would hopefully be no confusion in that situation. Even if what you use to compose the schema had a double bang in that position, what the client sees effectively wouldn't.
Yeah, and I think that's maybe, adds more to that confusion of like if you call it like kills parent on exception, it's like, well, that doesn't actually happen if you run it in in a certain mode, right? Which is like overly confusing from like just a bike shed naming perspective, I think, because it's kind of like, yeah, I understand what you mean by that, but like there's a lot of historical baggage of like what that actually did was like it literally did null out the parent, but it's like, well, not anymore, depending on obviously the mode you're running in.
But again, if you were to introspect a schema in no null bubbling mode, you wouldn't, unless you explicitly opted in to see the full details.
Yeah. I just mean as like a schema author, right? It's kind of like if you are the author and the consumer, it's kind of like, well, there's you're creating confusion for yourself potentially there. But yeah, I get it a little bit.
And to comment on what
Alex has had his hand up patiently here.
Oh, sorry, Alex.
Oh yeah, I was wondering if you could walk us through if I'm a user of Apollo or Relay, and Apollo or Relay, whichever one I'm using, has supported your proposal as someone using one of those clients for my app, what would sort of the upgrade path look like going from the current mode to no null bubbling mode? Are there any breaking changes there?
So I'm gonna pick on Relay because it's easier to talk about one thing than 2 things. I would imagine that Relay would just switch internally to always requesting no null bubbling mode. And so every single request that it sends out after what version are you on currently?
I don't know.
All right.
16?
So on the 17 release, it suddenly just turns on semantic or no null bubbling mode for every single request. And then it writes the responses to its store and it gets all the benefits.
And that, sorry, that switch by default would be non-breaking for the clients, correct?
Right. No, it would be non-breaking for an intelligent thing like Relay, because Relay would then.
Yeah, I mean specifically for Relay, yeah.
So Relay would be able to make that change and then emulate the previous state for all of Relay's users. Relay would have to do a lot of work to achieve that, but Relay would take care of that, and the client would then have the user wouldn't see any breaking change from the fact that Relay was making the request in a different mode. This is with a very intelligent client like Relay. Then Relay could make it so that clients can opt in maybe on a fragment basis, where they can then say, oh, I want the semantic nullability here, or I want, throw and catch, or whatever all the other directives are that are being discussed. And I know Apollo are discussing these things as well. I'm just picking on Relay because got the guys right here. So in that situation, so long as Relay supports everything, it would be fine. And then clients can opt in on a bit by bit basis. For clients that don't want to put that full amount of effort in, for example, a fetch client, or if you wanted to support it with an existing release of Relay or Apollo or Urkel, it would be a breaking change, because everywhere that you previously thought of as non-nullable can be null if an error happens. So you would need a way of handling that situation. But that's only.
Wait, sorry, is that right? I thought, wait, everywhere that you thought of, maybe I need to go back through the thing. How are how are non-pragma documents? I thought non-pragma documents were interpreted the same way as they were previously under non-null bubbling mode as they were in the standard mode.
That's correct. So changing a document is entirely non-breaking, and you can do that client or server without any breaking changes. It may be that your client or server doesn't support the semantic non-nullable, in which case you would get an error. Also, it may be that your client or server doesn't support the pragma keyword, in which case you would get an error. But assuming that neither of those were the case, it would be fine.
Okay, so this is a situation where the server has started upgrading. There are pragma files, and then you throw the switch.
So the switch that I was describing before was the client switch, where the client says,
right, that's what I'm talking about.
So if the client runs a request in no null bubbling mode, then nulls won't bubble anymore. So places which couldn't have nulls before now can.
Okay. Okay. Got it. So, okay. So by default, if you were using a non-smart client, that would be a breaking change.
Yes.
Got it.
Non-error handling client.
To be more specific. Yeah.
To
Okay.
be of the dumb error handling clients.
Oh yeah, of course. Throw out if a script throws out on any error, then
That's fine.
that script won't be broken by
Yeah.
this change. In fact, they'll get an even better situation than they were in before. I mean, to be honest, it'd be equivalent pretty much, but their type generation could be improved. But yeah, it would be non-breaking for them. If you throw out responses on error, then it won't break you.
Which is, I think, also a bit noteworthy, given that my understanding is that Apollo's default and error handling is that it discards queries with errors.
I know that it has an error policy, so you can change it.
Yes, but I think the default error policy is to discard responses with errors.
It might be.
I think writing down some of these user stories might be helpful for the proposal, talking about what these upgrade paths look like.
And so we are at time. For next steps, should we continue some of these questions and discussion in the doc with the comments and whatnot, and like while it's fresh in our mind?
You're more than welcome to do so, but I wonder whether moving it to GitHub would be wise. If so, I can file. What would be the most sensible thing? we could just raise issues in the repository to discuss various parts, if that makes sense. Maybe prefix them. I don't know. Maybe if we have discussions turned on, maybe we could
I
just
think
use a
we do.
discussions thread. Yeah, we've got discussions. So if I take the document, convert it to Markdown, and post it in as a massive discussion point, then we can have threads of discussion underneath that. Does that make sense? Yeah, okay, cool. I will take that. I'll do that. I'll do it straight after the meeting.
And would anyone volunteer to take a stab at like these user stories?
I can do that.
Amazing.
I just want to say another thing that I'm going to, which is a little bit related to this, but not strictly, which is I'm going to start to try to track down more client and server authors, and try to get them involved with even just our current like directive-based distinction, and to see if we can get a little bit more activity, so it's not just relay and grots. So if you have any people in mind, or if you are a company who might be interested in pushing this forward internally with whatever stack you have, I'd love to hear about those.
And happily, it seems like it should basically align with anyone who's been using the directive approach anyway, because really it's what we're talking about there is a syntax change.
Yep, right. We can continue our experimentation using the directive syntax.
If you wanted to get people in the Federation world, I would recommend looking into the Open Fed spec and probably WonderGraph or Cosmo. I don't know what the company calls itself, but that's their two things. The people I'd go to, or the guild maybe, but yeah, not for how much. And then Apollo as well on the other side of it, the Apollo Federation spec.
Yep. We also have the schema composition working group as well, so that's another place to raise it.
I know Stellate at one point was doing caching of GraphQL. I could imagine anyone who's doing edge caching of GraphQL data would also be interested. I don't know if there's anyone actually actively doing that, if they're doing normalized caching.
Cool. So talk to anyone about it that you think might be interested.
Cool. It's great talking to y'all.
Thanks,
Awesome. Thanks, everyone.
Thanks.
Benji.
Yes.